All right, good morning. We're going to extend the discussion about linear relations in algebra and see if I can do another one of these. First off, let's talk about the homework stations that I gave you. People seem to have a little bit of fun with those. I want to make sure that you have an understanding of what we were working on there. It is just continuation of going from the pattern to creating a t-table and then plotting it. T-tables are key for algebra when plotting things on a Cartesian graph. So today I'm going to go over and talk about the different ways you can look at a Cartesian graph and all the different principles that we have. Up here, what I have, nice and simply, is a pattern, its equation, its t-table, a graph, all right? And we're going to look at how we can do all of those things as simply as possible. So I start off with 2, 5, 7, 8, and 11. And I notice what's happening there. I notice an increase of 3 each time. So I'm going to see. Now, the thing is, this is a pattern in positive numbers. So we have a pattern in positive numbers. We can only work in positive numbers. You'll notice on my t-table, however, I start in negative numbers because it's always useful to have negative numbers on a t-table so you can see things when they cross the y-axis and you can see them in the negative values. But let's start with our values here. So we have t values of 2, 5, 8, and 11. All right? So 2, 5, 8, and 11. I'm noticing an increase in 3 each time, but I want to recognize that I'm increasing by 3, and in that increase by 3 is its multiple, which ends up being the slope, by the way, and we're going to get to slope in a minute. That increase in 3 each time becomes our multiple, all right? But 3 times 1 is 3. How do I get to 2? I need to subtract 1, right? 3 times 2 is 6, subtract 1. My 0 value, 3 times 0 is 0, subtract 1. So I would have a negative 1, and that tracks 3, 3, 3, and then negative 4. Those are my values. All right, so 3x, 3 times y is equal to 3x, all right, minus 1. Now, before I talked about the variables, and there was some discussion about that. Somebody came back to me on this one. In the textbook definition of these things, they talk about y being your dependent variable because it's dependent upon everything else. But really, y is a solution. So my variable, or my equation, is 3x minus 1. This is the constant. Scientifically, if you're talking about the scientific model and comparing it, there's your constant. This is the independent variable because it changes dependent upon what value you give it. It changes, right? And this whole thing is dependent upon what value that is, all right? So your end result is a completion dependent upon all of the different variables completed. But yeah, I can see how because y is theoretically an unknown, they're calling it a variable in that way, yes. But you really have the dependent, independent, and constant occurring in an equation. So any scientific experiment is an equation, nice and simple. All right, now we plot this. Plot this at the 0, we go to negative 1. At 1, we go to 2. All right, 1, 2. At 2, we go to 5. All right, and then from there, we just take a ruler. I've plotted 3 points. Plot 3 points. All right, and there I have my line, and then if I'm doing this properly, if I'm going to do this properly, I will label my line with the equation. So you always label your line with the equation 3x minus 1. All right, so these are your 4 basic formats for any linear relation. Obviously, your equation is key. It explains everything. The t-table is a good visual to show you the pattern increase, like a visual pattern like this, in a more structured format. And then graphing the line is what you're going to be looking at. Now, there are 2 other things we want to talk about. And those 2 other things I want to talk about are, we want to look at the slope, and it's, I was hiding it. Didn't want to distract you. Coordinate points. There we go, good. Coordinate points and your slope, all right? Coordinate points and slope. Your coordinate points are any series of points along the line, and they can be taken from anything on this chart. What you do is you would then take something that is further along the line, or previous above the line, or below the list you have on your t-table, or something on your t-table as a set of coordinate points. Anything would work, like this. 2, 5. Is 2, 5 on this line? Well, yes, 2, 5. Right, 2, 5 is part of the line. All right, those are coordinate points. Having 2 sets of coordinate points on your line suggests that you are in the right, you have the right line, because it's a straight line. So 2 points connecting would be confirmation that it is a line, right? So you just need 2 points in a line to prove the connected line. And then slope. Now, slope is something that you're going to be looking at next year specifically, and slope is taking any 2 set of coordinate points, your x and your y's, and you put this into this equation where you take your second value, y, usually the one closer to the y-axis, your second value, and it doesn't really matter which one you use, your y2 minus y1. So in this case, I could take 2 minus 5 and 4. Oh, sorry, 2 minus 4. My apologies. 2 minus 4. No, yeah, 2 minus 5. I was right. 2 minus 5 and 1 minus 2. All right. They give you negative values of -1 and -3. All right. Translate that into positives in this case, and that gives you your slope, because -1 over -3 over -1 is the same as +3 over +1. Subtract, get rid of the negative. The value is 3, which happens to be your slope, right? And that's the slope of the line. Now, slope is something that we use mathematically when determining algebraic equations, but slope is also called rise over run, and that is what is used when contractors and builders design roofs. So they need to know the slope, the rise over run of a roof level, right? How many feet across, or how many meters across, or how many meters up, all right? And that's what you want to be able to design. So a slope of 1 means for every 1 meter over, you go 1 meter up, which is a 45-degree angle. A slope of 2 is for every 1 meter over, you go 2 meters up, which is a, anybody, 60-degree angle. And a slope of 0.5 is a 30-degree angle, right? So for every 2 meters over, 1 meter up, that's 0.5, right? So that's how you're able to do those. Now, I've posted a little activity, or I'm posting a little of activity for you guys to figure out these patterns, these 5 things, and they're all jumbled up, and you have to put them together in lines. So that's your next activity for right now, and we'll be posting more as things go on. Hope that helped.